Here's a really good table that kind of summarizes everything we discussed in this section. We have the different reaction orders, the rate laws, and I love this part, the units. You don't have to stress out about doing it yourself. You can just look at this table. We also have the integrated rate laws. Because this is online, you're not really going to be required to know this. Also, this is going to be given to you on the ACS exam if you do take an ACS exam. If you're online, you're not. So don't worry if you're going to be taking an online course. But you can come back to this table or write this down. But if you are asked something like this on the exam, they will slip in the question some point if it's 0, first, or second order, and you're supposed to instantly know what integrated rate law to use. So if it is a 0 order, you have to use this rate law. If it's first order, we discussed the natural log, and then the second order, the 1 divided by. So in the 0 order, your plot, if it is going to be a 0 order reaction, if you plot concentration versus time, you're going to have a linear plot. That's how you know it's going to be a 0 order. So the slope's going to be the negative k. And then for first order, if you plot natural log of a versus time, it'll give you a linear plot. And then the slope is going to be negative k. So they're both going to be negative. For a second order reaction, if you plot 1 divided by a versus time, you're going to have a linear slope, and it's going to be a positive slope. And then here are the half-life expressions. So how do we determine what order your reaction is if we just are given experimental data? So what happens is we will give you a table, and you're going to plot it 3 different ways. Whatever one has the most linear plot is going to be the order at which that reaction is. So we always start with the plot of concentration versus time, since that one doesn't really have any effort. If it is linear, you don't have to do any more plots. We already know that reaction is going to be 0 order. But if it's not linear, as in it probably has a curve, we have to then plot for first or second order. If we plot natural log versus time and it's linear, then the reaction is just going to be first order. If that's then not first, if it's not linear, then we're then going to plot 1 divided by a versus time, and if that's linear, it's going to be a second order. So essentially, you're given data and you plot it 3 different ways. Whatever the most linear is going to be the reaction order. Example 14.10 says data was collected for the reaction A becomes products by monitoring the concentration of the reaction over time. Part A says determine the reaction order with respect to A. So we're going to have to plot this using either Excel, Origin, your LabQuest if you were to be in lab. So we're going to plot this 3 different ways. We're going to plot concentration versus time. We're going to plot natural log versus time, and we're going to plot 1 divided by concentration versus time. Whatever one gives you the most linear is going to be the order with respect to A. So we've plotted each of these, so time is always going to be on the x-axis. And we need to decide which reaction order is. It should be relatively easy to decide. So out of these 3 options, which one's going to be the most linear? It's going to be option 3. And I know that it's going to be a second order because option 3 is a plot of 1 divided by concentration by time. And the good news is once you have a linear graph, you can actually find the y equals mx plus b and go further if they ask more questions. Part B says calculate the rate constant for this reaction. This is going to be relatively easy. So if y is equal to 1 divided by your concentration over time, your slope is just going to be equal to k. X is going to be your time, and your y-intercept is going to be 1 divided by your initial concentration because this is a second order reaction. So because I know my slope is just equal to k, my rate constant is just going to be 0.0023. And looking back at that chart, I know that the units are going to be molarity to the minus 1 times second to the minus 1. So this is really easy if you're given a equation from that linear chart, or sorry, that linear graph. You just got to find what the slope is. If it was a first order or a zero order, then you would be given a negative slope, and that k would be the positive value because k's are always positive. So that's important to remember.